Hello everybody, I am Rajesh Adhyapak, GM Technical Head from PELF Infotech, Pune. So today I will be talking about a whole new technology, a whole new world of 3D printing. So we talk about the two new different technologies. The one is FFF, that is fused element fabrication technology, wherein like we print the plastic part along with the composite reinforcement. Traditionally, like we know that we have the parts in plastic, maybe nylon or ABS, so they are called as parts for designed for prototype manufacturing, just to see the form fit type of design. Going beyond that, they can also print the parts, so they are actually functional prototype. They can be directly put into the application under the constructive loading and repetitive testing. The first part over here is this is the part in carbon. So we print this part in carbon. It's a continuous carbon along with the onyx as a base materials. We print the part in two base materials. The one is plastic, nylon plastic. The another is onyx. The onyx is actually nylon along with the chopped carbon mat. That is the base resin matrix. And then like we can reinforce this part with carbon, with Kevlar, or maybe this is the Kevlar, maybe fiberglass also, depending upon the functional requirements. We can also insert the parts whilst printing or after printing. So these are not only the prototype manufacturing parts, but they can be delivered for the functional prototype. So they can actually replace your existing part into design. This carbon being a very high strength material which provides you the highest strength to weight ratio, and also the other material properties like we also have the high temperature, high strength fiberglass to take care of the strength to weight ratio as well as the high temperature requirements. Talking about this, so we have an example of a snap joint. So this is a nylon material. So nylon offers you a kind of a flexibility, and this is chopped carbon mat. This is chopped carbon mat, and we can see. So we can have a snap joint like this. It's an example of a robotic fixture. It's a robotic gripper, it's a robotic end effector. So this is actually a chopped carbon mat, and so this part of the gripper is exposed to the abrasion. So Kevlar is having an excellent abrasion resistance, so we can just put the required amount of Kevlar over here. Likewise, we can add the different composite depending upon my requirement. So this is actually an end customer part, so which they have replaced their aluminum parts, aluminum grippers by this material. The beauty of our product in 3D printing technology is the honeycomb structure. It's a honeycomb structure, so which provides you a better strength. We can also print the threads. So this is a ball joint, example of a ball joint. Now if you see, so these threads are also as printed, and like we can go from M3 threads and above. So this is a whole new technology for composite parts printing. Let's talk about the metal printing. So we have a new technology called as ADAM, Atomic Diffusion Additive Manufacturing. So this is for the metal printing. So we design the part in 3D. So we print the part in the printer, in the metal printer. Then we remove the plastic layer. Then we oven it. We put the part into the oven for heating, where the part is heated for 1300 degrees, and wherein the wax and the plastics get debinded. They get removed, and then we get a solid part. The beauty of our design is traditionally for all the metal 3D manufacturing processes, the support material. So they are actually glued to the base metal part, and it is quite difficult to remove those support material. But in our case, in our technology, we have ceramic layer. So that layer will differentiate between the support material and the the base material, which we can easily peel it up by hand, because ceramic being brittle in nature, like one can easily chip it off by hand. Thank you.
The mechanical engineer's eternal problem is waiting for parts. And with 3D printing, that whole cycle of design and wait goes from design and wait 6 weeks to design and wait a day, which is basically everyone's dream.
BattleBots to me is somewhere between a hobby and a career, right? It's not only what I cut my teeth in engineering on, but it's what I helped many, many new builders come into the sport doing. With the Markforged printers, it's the reliability that honestly gets you every time. If you can't trust your printer to leave it alone overnight, then you're not getting anything done any faster than you would with a conventional method. It's a super low effort, and I like low effort. Engineers, we're finding more and more lazy ways to change the world.
Somebody once asked me why we put so much effort into how the printer looked and how it was built. And my answer was, if we don't care about how our product looks, why would you believe that we're going to care about how your part looks?
This is industrial. I mean, this is a different scale. It's insane, to be honest with you, when you can think you can actually print a metal piece. I'll take the carbon pieces. I'm a carbon guy, a racing guy, carbon fiber the whole way. But it's incredible.
This is not looks like, feels like. This is like works like, keeps working like, and you forgot that you 3D printed it because it's still working.
Most of the work that I do is in the orthopedics and trauma realm and trying to make a difference in people's lives. What I'm holding in my hands here, this is a external fixator part. Each kit that basically used for a patient costs about $2,000 to $3,000. And this one is a 3D printed version of that. It costs $5 that does the same thing, and you can throw it away and don't feel guilty about it.
Our customers who are using our printers, they have parts on their desk that they're showing how much time and cost they've saved.
The Markforged products affords us the ability to take greater risks.
Having the ability to print something that's not as expensive kind of rekindles your imagination.
Originally, 3D printing at Dixon Valve was for research and development. And over time, as the technology advanced, we took it from rapid prototyping into functional prototypes.
We can go in entirely different directions because we will be able to produce things that you can't produce other ways.
At the end of the day, every engineer just wants to make a perfect design. 3D printing lets you get a little closer, or a lot closer.
To understand the profound impact of being able to 3D print metal parts like these, just look around you in the world around you.
This is industrial. I mean, this is a different scale.
With Markforged, every year is like a new breakthrough.
With this new printer, you print materials you already know how to use. There's no learning curve.
You can bring that magic right into your office. You start to print tonight, and the next day you're holding it in your hand.
You can print titanium, magnesium, you name it, and you actually have working prototypes.
If you can afford a $500,000 to $1 million metal printer, buy one. For the rest of the world, this is for you.